Here we go.
All right, you seen the first method, finding field order. Okay. Now we're going to go through the second method. Along with this one, I'm going to include 2 other principles. I'm going to go on through the other 2 principles out there for you. Boogie, you were asking for them, so I'm just going to give them to you so that you got them. And then I'm going to use the periodic table, which is my method that I prefer.
Do you think this method's easier?
Yes.
Yeah. Like by a significant amount? Or just by a little bit?
A lot.
Okay, then I'm going to go through method.
Yeah. All right. So the second principle we're going to talk about, okay, we've talked about off-ball. Now we're going to talk about the Pauli exclusion. The Pauli. And I'm not talking Rocky Balboa Pauli. Okay?
What?
You never watched Rocky.
I never watched Rocky.
You've never watched Rocky?
I watched like the one.
You need help.
There's like the one when he's running through Philadelphia. Goes up the stairs. He's like, Adrian!
He never said that on the stairs.
I know.
Just be quiet.
In my mind, he did.
Just be quiet.
It would have made a better movie.
All right. So the Pauli exclusion principle. Make sure this is on camera.
Make sure I'm on camera.
Yeah, we're good. You're not on camera. Pauli exclusion principle. This is what the Pauli exclusion principle says. No 2 electrons.
Pauli, do you make this?
Okay? No 2 electrons in the same atom can have the same 4 quantum numbers. So go back to what I've said before. We're doing configurations before we do the quantum numbers. It helps. I don't know why, but it helps. Okay? So the Pauli exclusion principle is our second rule for electron configurations. It states no 2 electrons in the same atom can have the same 4 quantum numbers. These 4 quantum numbers, it works like a zip code. It's kind of like, 24870 is Oceana, West Virginia. It's not Beckley, West Virginia. It is Oceana, okay? And nothing else can occupy Oceana, West Virginia besides Oceana, West Virginia. No 2 cities can occupy the same place. It's either one or the other.
You know what you just now done?
What?
You just now gave our location on the YouTube.
If somebody really wanted to dig, they could find where we are. I mean, like everything's
I
tagged
like
together.
really know where we're at.
All right, so there's the Pauli exclusion principle. Now we're going to talk about the last rule for success. This is called Hund's rule.
Did the Hund make this? Why do all these people have weird names or whatever?
I don't know. I'm going to name my kid weird and see if he becomes a scientist.
I named my kid Gilbert. Boogie. Sir Boogie. Gilbert McCombs.
So orbitals, okay, of equal energy.
Gilbert Middle School. Someone named my kid.
So orbitals of equal energy, each gain 1 electron before any of them gain the second. This is Hund's rule. Some people will refer to it also as the empty bus seat rule. So empty seat rule if you want.
You know what sucked when you had a seat by yourself on the bus and somebody just come and sit with you?
This is what this is talking about. It's the same idea. So if you get on school bus in the morning and you walk in and everyone has took a spot in a seat except for the one in the very back, which seat are you going to fill? The one in the very back. You ain't going to be sitting around with people. You want distance. Nobody wants bunched up, especially if there's a big fat guy sitting in a seat like me. Who wants to be sitting there all squinched up? I mean, nobody wants that.
First of all,
So,
why wouldn't the people that's already been there not go to the back? Because it's the best place on the bus.
okay, look, hey, this is my scenario and it serves my purpose. So just listen.
No, back of the bus is the place.
Y'all gonna have this debate later on? Which seat is best on the bus? Okay. So, this is the same thing. All this is saying is that this electron is going to fill these orbitals. If it's the same energy level, it's going to fill each orientation with one before it gets a second one. You're going to see what I'm talking about later on. Okay? Are there any questions with the three rules, principles for electron configuration? If there is, now's the time to ask.
I have a feeling we're going to be on the quiz.
Huh?
I have a feeling these are going to be on the quiz.
Okay. Everything's fair game.
Yeah, it's going to be.
All right. I'm going to show you method 2, but I got to lay some foundation for method 2. So I'm going to move really fast here. This will be on the video, so you can go to YouTube and you can watch it and be like, oh, that's what Mr. Hall was doing. That's what he was saying. Now I understand. Just make sure I got this in the shot.
They're just trying to get more views.
Huh?
They're just trying to get more views.
That's exactly what I'm trying to do.
Money.
Yeah, you know, get past my 47 views. All right. So,
Yeah, 75 the other day.
cool. All right. First thing is your periodic table. You got to break it down into blocks. We have this periodic table broken into blocks. So, from here, these first two columns are what we call the S block. Okay? Columns 1 and 2 make up the S block. Columns 13 through 18 make up the P block. So columns 1 and 2 make up the S block. Columns 13 through 18 make up the P block. And then you got the columns 3 through 12 get a little different. 3 through 12 is just here. It's in the middle of the periodic table between the S block and the P block. So you get a different color. Let's use red. You can distinguish between red and purple. Okay. Just making sure. So right here, so columns 3 through 12, it's in between S and P. This is the D block. Feel like we're talking about prison yet. S block, D block, S block. All right. Have you ever wondered what's these down here? Why are they down here? Why are there two groups down here? Well, this top one here. Okay, this is the lanthanide series, and then below it is the actinide series. These guys down here at the very bottom. Are what we like to call the F block. They're like in solitary confinement. They're in the worst place.
Aren't those dorms like highly radioactive?
Yeah, a lot of them is really radioactive. But these guys down here are radioactive as well. Really cool thing is you can look it up later on. I can't discuss it right now, but actually there's been new elements synthesized and created. Pretty cool. Yes.
Is helium part of the P block?
Wonderful question. I'm happy you asked. Helium is here because it's part of the noble gases. But helium, for electron configuration purposes, fits over here next to its best buddy, hydrogen.
So it's in this block.
When you're doing electron configuration, helium will go for an S block. That green marker is done for.
Are you going to give us like a periodic table or chart?
I gave you one.
Yeah, but this one doesn't. This one sucks.
All right. So with this will help you to find this field order. You got to start. It's literally just a roadmap. This is all this periodic table is. Once you break it down with the information, the key to it is you have to break these rows down. Okay, you're going to use the row you're in, and you're going to keep rolling with it. How long have I went? I'm good. I should be able to do this. Okay, so this is how you're just going to go. That's been down there a while. It does and everything. All right, what row am I in? First row, which block? S. So 1S. Am I right if I do green? Okay. So 1S. Then you go from 1S, drive across, you go to the second column, you go to 2S. You drive across, you're hitting nothing until you get to the P block, you're in the second row, so it's 2P. Or not 2P, that is the question. Hi, mark it up 2 times across the curriculum today. Booyah. After 2P, you come back to 3S. And then you drive across and you go to 3P. Everybody okay? Then we go 4th row. It's S block, 4S. Now this time it's different. You come into this D block. Whenever you're doing configurations and you get to the D block, you will always take, so this is for the D block only, always take the row -1 to get your number. So what I'm saying is, what row am I in right here? I'm in the 4th row. I get to the D block. You subtract 1 from the 4. Gives you 3. So you'll have 3D. Anybody confused on that? Go back and watch the video. I don't know how many times we get to here and everyone's like, well, that's simple. And then we get into doing these and they're like, I don't understand. Why? What's going on? Why are we doing this? What happened? Okay? It's as simple. You get to the D block, subtract 1 for the row. Alright, then we go back. Through the D's, back to the P's. So, 4P. You come back, 5th row, 5S. You go through 5S, you get to what? 4D. Why is it 4?
Because you subtract the row number by 1.
Thank you. Please don't forget it. I have so much hope in you. You are so brilliant, intelligent. No, I'm being real. Y'all really are smart. 4D. Okay, the 4D. Okay, after 4D, we're going to 5P. Okay, after 5P, I come to 6S. Now, this is where things get interesting. Look what the difference in these numbers. Once you come from 56, where do you find 57? Here's 56. You may not be able to see it because this is really old. Right down here. You start in the F block. Here's the rule. This applies only for the F block. You take the row and subtract 2. So, what row are we in here? 6, drop down, 4.
4S.
How about that? So 4F. And then you keep going, you come back up to 5D. And then you get up to 6P. Then after 6P you come back to 7S. After 7S you come back down to the actinide series and you come to 5F. Then after 5F you come back up to 6D and then you finish off with 7P. As of right now, that's as far as we go. Any questions behind breaking any of this down?
Why did you press 1 and 2?
Here?
Yeah.
Okay, it's differences in energy levels.
Do you have to do that, or you just do that other method?
You can do that other method if you want. I'm giving you two options. If you look at your fill order that we got from that first method I showed you, is it not 1S, 2S, 2P, 3S, 3P, 4S, 3D, 4P, 5S, 4D, 5P, 6S, 4F, 5D, 6P, 7S, 5S, 6D, 7P? It's the same fill order. The reason I don't like the first method is a lot of people can mess up when they're coming across with their arrows. But whatever works for you, absolutely do it. I do not care. It's kind of like when we did metric conversions and I gave y'all my method. You didn't have to put it in scientific notation. You just had to manipulate the exponents. Okay, but then some of y'all want to put them in. Whichever way works for you, do it. Other